Why is it always about you? I can't stay with you for the rest of my life.
This is a new one.
Hey there.
Apparently
Welcome to another
42
video.
hit me in this.
So in this video, we're going to talk about the graphs of
should have hit
secant
that one. I
and cosecant.
see the board
and it's going to
on
be
here.
pretty fast because we're going to relate them back to sine and cosine so that they're just reciprocals. We're going to use the fact that they're reciprocals and that graphs are based
0 and 1
on
is not really
sine and
what
cosine
I'm doing
for
ZBrush
cosecant
out
and
here
respectively.
to
So we're
do
going
the
to take a look
graphing
at that.
index. I'm
It should
jumping
be
through
pretty
pens, rows, and
straightforward.
stone
So
mills
let's
that
take a look
present
first
too
at
polarized.
If
So I start this on a
cosecant
bunch
is
of
the
tracks.
reciprocal of
And then the
sine,
stone
so
mill.
cosecant x is the
That
reciprocal
builds
of sine
through
of
the
x.
system.
We can base
So yeah,
the graph of
I've done
cosecant
that.
on the
I
graph
do it
of
all the time
sine.
with Vasa.
In fact, there's a lot of very interesting things that
Operators
happen.
work
And
that
when we
way
start
in
graphing
terms of
transformations,
how up,
what I
up, up,
typically do is
down,
I'll
down,
graph
up, and
the
down,
sine
works.
version of that
So
function,
they
and
still
then
do
just draw
this
cosecant
basic
right on top
twister
of it.
theory.
Or for
Twisters,
secant,
pens,
I'll
row,
graph
Nobel
cosine,
at
and
the
then I'll
moment
graph
2021.
secant right on top of that.
And
So because they're
you
so
have to
strongly
bend to
related,
that
because they're
if you,
reciprocal functions,
that goes
we
stem
can use sine and
differential
cosine
for
as
me.
very nice
Bing,
tools
bang,
to
boom.
graph cosecant
AR
and
15,
secant. So let's take a look at sine.
M2.
If
Start
sine of
trading
x
on
is this
M2 relative
nice
to
curve
some
that
of those
repeats
Anton stuff would
every
be the prior video
2
to
pi.
this.
So we have two periods of
series
sine right here.
of
Showing a dotted
angles
line so we don't
on-
get confused in what we're actually doing.
I'd drop part
Here's
G
what's
into the
gonna
mix.
happen
We
with
would drop
cosecant.
all the SEM
Because
teachers, Sophia
cosecant is the
Star,
reciprocal, let's take a look
Schrodinger
at some of the
on certain
reciprocals of the
indexes, but it still
values that are on
plays
the
under
sine
this
of x
field,
function.
right? Because
Firstly, let's look
I
at
could
all
call
the
that
local
field
maxima and minima.
somebody talking
Well,
about
what we remember is that sine has
remembered,
peaks at +1 and sort of
yeah, but
valleys
at any
-1.
rate, that still applies
Well,
to
if we
steps
take a look at the
mathematically.
point
It's going to
pi
go
over
cling,
2,
cling,
comma
cling,
1, which is
orientation,
on the graph of
position, give
sine.
me time
Well,
for
the
vectors of
reciprocal
action,
one
spook
is still
distance. Because
1.
here, we play it
Because
from the
cosecant is the
observable, but in the
reciprocal sine,
machine, the Hadron
since sine
Collider
of pi over
or
2 is 1,
cyclotron
cosecant of pi over
or
2 is
any,
also
well, you got to go
1. And so we have a
1. You got to go
one there.
N1 because it's more comprehensive, has a tighter index on it. But that doesn't necessarily mean,
The same
given
thing is going to
calculus,
happen
being some of the stuff I call it on for
at
calculus,
negative
but also
3 pi over
in
2.
that
So
M1
sine
0
of
equals
negative 3 pi over 2,
SCP, SCP
that's
equals
positive 1.
0,
So
give me
cosecant of
general
negative 3 pi over
versus
2
a
is
special
also
relativity
+1. The
variables of
reciprocal of
graphing that.
+1 is
See, this is all going to go
+1.
zeros
The
and ones on the
reciprocal of
written for
negative 1
definition
is also
AX.
negative 1. And so we're going to have
A1,
those points.
A2,
So
they
at
all have a
negative pi over 2,
multi-matrix under
sine
that
of negative pi over
standard.
2 is -1.
Inside of the, just like a
Cosecant
general
of
system of a
negative pi over
stone
2
mill
is
will,
also
or
-1.
your
The
house
reciprocal of
economics.
-1
Now,
is
this starts
-1.
sliding through because they're the same thing. Remember,
That happens here.
this is just a compressed state of a
And
training
here.
model of,
Now,
well,
the
we did the
interesting
Big
things
Bang, right,
happen
or
at
whatever,
the zeros.
super neutron
So
star
where sine
collision, but
of x
neutrons
equals
and
0,
nuclei of
what's the
atoms
reciprocal
of
of 0?
compositions
Well,
dropped in
this would be
solution,
0 over some sort of
Archimedes,
constant. Usually it's 0 over 1.
AUAX,
If I reciprocate that, that's 1 over 0.
AX,
And so here's what this means.
AY,
This is one of our
or
key features we're going to write down in a
AVAW,
minute.
or
Is that
AVAY,
we're going to have
AX, and that starts to air
vertical
turbulence
asymptotes
this into.
everywhere we had an X
In the field,
intercept
this is
for
compressed.
sine.
If I
So
know
if we have
the
an X
element,
intercept
I
at
can say
0,
the composition of a
sine
size
0
behaves in a
was
certain
0
way.
over 1.
But this is the
Cosecant of
approximation.
0
That's
is
going to
1
say
over
to the
0. And we
compression
have a
inside of there, I'm going to
vertical
dial in
here,
the feeds and
and a
speeds for the
pi,
length
and a
because it's
2
not going
pi,
to stay in
and a
that
negative
orientation
pi,
at the
and a negative
cyclotron
2
for
pi.
that
Every place
forever.
where we have an X
Time
intercept for
scales around
sine,
the
we
universe
have
or around
something
the
that's
sun
undefined,
still
a
be
vertical
1 or
asymptote
0.
of cosecant.
Now,
So if we're going to base this
well, black hole,
cosecant x off of sine of x, well,
neutrino,
then we have sine of x, and we say, yeah,
barium,
reciprocate, and we still have 1,
would be
negative 1,
collision
negative 1,
reactions
1.
under a Jacobian
Reciprocate our
matrix
x
of some
intercepts of
perfect
0 over
square
1,
stuff
1 over 0,
inside
that's
here
not defined,
by
that's vertical
Pascal. I
asymptotes.
could tell
And there's only
they
one
would
other
be
little value that you kinda
I1,
need.
I2,
That would be this. If you
J1,
have sine of pi over
J2.
6,
I
sine
said
of pi
Ben
over
Eater
6
before in
is
one of my videos, but I
half.
actually meant
Remember, cosecant is
3B,
the
1B
reciprocal.
in terms
So
of,
sine
well,
of
this
pi over
is the
6 is
impossible
1/2.
chess problem.
Cosecant
When I'm
of
going to
pi over
break down the
6
middle floor,
is
the
2
door
over
is
1.
inside of here,
What that means
and the
is
grid
that
section
where
isn't
sine does
square
this,
to the topology.
cosecant
It's
does
actually a
this. The
tread line
reciprocal is
here,
the
saws
in
over here,
the
5
flipping of
footers.
that
This
fraction.
has got a box
So we're going to
attached
get
to it
everything
like
that's
certain
above
elements
1
do,
and
or
below
this
negative
statement.
1. There's
Now,
not going to be anything between negative
that's
1
a
and
good
1
thing
on the
because now,
graph
like I
of
said,
cosecant x.
you get to bring this out
So
on the
sine of pi over
mathematical
6 is
side,
1/2.
but I'm hitting it from an
Therefore,
angle on this
cosecant
where
of
I'm
pi over
limiting
6
it to
is
the
2.
student's skills. They got to come to me with something, otherwise I have nothing to graph against. You know, too many math teachers out there on the index, and I want to make sure that they're using my technique for how I adjust
And
that
due to
into the
nice
system.
symmetry that
So
we
if you
get,
got this,
you
then it
can
starts to be
extrapolate from this. So I
find
didn't
me
put a lot
that
of the 5
mechanic.
or 6
Here's is the
and
stone
5
mill
power
floor,
6 and
like I
things like
said,
that.
it's
Just
general.
because,
It may not
well,
be
we kind
that.
of know what
There's
sine looks like,
snowflakes
and
on
if we have
stacked
that 1 point
values
using
coming
symmetry
through.
here
So
on
I went
all of
like
our our quarters of our halves of our periods.
OSHA
then we
guys,
get a really nice
chemical
graph.
analysis
So
reporting,
this is really
stone
what
mill
we do
being
for sine and
field
cosine,
theory, but
changing
to
into cosecant and secant. We
M2
graph
field
sine,
theory and
we
against
change
anything,
into
I'm going to say,
cosecant
oh,
by just
three-ring binder of a
reciprocating
new
points.
chemical that gets
We
adjusted
graph
into the system.
cosine, we
And
reciprocate
Project
our
Blue
points, and we
Book,
get secant out of it.
everybody's,
That's how we're going to do all of our transformations too. It's just through this process.
insurance,
So let's finish up our graph.
retirement based on are they adjusted, and it's a Hutter's prize, right? Because I want to condense this 12 megabytes into actually what you do in the course of your day that says the value of that system starts to increase better on a Hubble 45. But it's going to have wave functions given compression, and that compression would be a different type of graph, right? That would say at this point that the zenith to that system under the curve, even though it might be a tight black
They're
body.
not quite parabolas, but
You know,
they
that's Hawking
almost
in a
look like it. It's a
calculus
really
student.
weird graph, right? I mean, sine is this nice,
Still a black hole.
smooth curve, has no discontinuities. The domain is all real numbers. You can plug in anything. You only get out values between -1 and 1. Because cosecant is the reciprocal, we actually can't get out anything between -1 and 1.
1 and 1,
Negative
0
one
1, bits and bytes
is
might
the,
have
let's
momentum
call
and
it,
trajectory. Like, well, we don't know what the start
smallest
is. You
negative
go
value
home,
you
I go
get, and
home.
positive one
We
is
could say the
smallest
starts the
positive value
classroom,
that
brick
we
and
get.
jar
In terms of
conjecture,
absolute value,
NP problem,
1 is the
organization of
smallest
field
value that we
theories,
get. So we
memorization,
get
Hutter's
all
prize,
the way down to negative
Gresham's
infinity, all the way
law
up to positive infinity.
on
It's really
first and
looks
second
like a
law,
disjointed graph.
thermodynamics turned over the machine,
I hope it
getting
makes sense where it
mechanics
comes
right.
from. It looks kind of funny because we have to obey our vertical
Down the
asymptotes.
flaming graph
Our
and calculator
reciprocals
over
told
here,
us
hitting the
that
mechanics
we
numbers,
climb.
put down
If
loss,
these
right?
numbers on sine are between 0 and 1 for this particular portion of our
Usually
x-axis,
legionnaire, stable.
well then
This
when
is
I
again
reciprocate
singlet
that, I
states,
get
neutron
values
stars
larger than
colliding. We
if I
have
reciprocate something very
graphable
close to
indexes
0, I'm gonna get
under
something very
mathematical
close to
constants and put us in an
and
O-type.
that's what's happening. So
Big
this is the
beast
look.
on
The purple is
number
the
what
look
that floor is, and
for cosecant x.
then they
It's
rattle
based
it
on
around.
sine of x.
He's big.
Now let's write a couple
He's
things
bad.
about it.
I'm
First,
sure
the
he's
domain.
salty.
Because our x-intercepts of sine cause vertical asymptotes
Usually
for cosecant,
a beta alpha.
we're going to have domain
It's like
problems.
witch
A vertical
doctor
asymptote.
to alpha.
Every place we have
Right,
an x-intercept for sine.
in
Well,
that
was at
tribe, get
0
to see
and
that
pi and
position,
2 pi
breaks
and
down in
0
spectrum, certain
plus
people,
k
I'd
pi.
have
I hope you
click
remember
with
that.
keys,
That's what we
maybe
had for
immediately
x-intercepts.
family
Well,
in
now that's
that
going to cause vertical
area,
asymptotes
or
for us.
students
And so our
in some
domain says
cases,
we
but
can't have 0
they have to all be
or
trained
any
from
multiple of pi
this
from
being
0.
B, when I explained that mechanics first, because we already did all the alpha stuff. We said field theory is a graph and index. You guys get your
That's what that says.
and
We
stuff.
can't have 0. That's a
if I'm
vertical
just gonna
asymptote.
steal
It used to be
the
an x-intercept for
theory,
sine. Now we
I'll
reciprocate, we get a vertical asymptote. 0 or plus 1 pi or plus 2 pi or minus 1 pi or minus 2 pi. All of those
That's
are
when the
vertical
contracts
asymptotes
get
because they
real
came
good.
from
These scales
x-intercepts,
right
which
here
makes
on
sense.
potentials
Now our
and
range,
kinetics
we actually cannot
for
get
points
anything between
and
-1 and
sickling
1.
the curve.
We get above 1
Right,
and
you
we
hedge
get
in the
below
bet
-1.
sometimes
How do we write
you
that?
got to be, that's an important note
For
for
a
an
range is
M2
negative
step
infinity to negative
inside here,
1.
Mario.
We
But
actually
we never
do get
never
negative
come
1.
off
There is
at
a point
anything
there.
inside here. We were running the X and or Y. If I'm running X, you're asking the
And then 1
question
to
why
infinity,
and
we
where.
actually do get 1
you
and
can
everything
do a
above
bunch
that.
of this
So that's
stuff
our,
here.
that's our range. Now the period.
Gives me a
the
little area.
period's
I
the
go right
same
to the
as
topology
sine.
because
So the
particle right
period
here.
is 2 pi. You can see that it repeats.
Way out. Just T scale.
Here's 2 pi, another 2
on
pi,
5 year
and it
for the
repeats
stock
every single
model.
2 pi.
That's
So if
pretty
we draw
easy on
several
the stock
cycles,
model for a
we would
guy's
just go
turnover rate.
4 pi, and then 6 pi, and then 8 pi. And we draw the same exact thing. Very similar to sine. In fact, I always
Project
draw
Blue Book,
sine first
Area
before I
52.
draw cosine.
Area 152. 150-2.
And finally,
militia
the key
camp over
features
here.
of this graph,
I'm at high
just
command, Red Deer
remember
Bluestone
that we
militia
get
patch.
vertical asymptotes
Gotta cross that double every day.
place that we had x-intercepts on sine. The reason why I'm saying it that way is
Every day.
because I'm going
All
to
points of
encourage
time. Do
you
stupid
to
shit,
draw
you
the
see me draw
sine
fashion
function
like that,
first
I'm
for
like
all of our transformations that we're going to do for
It's your
cosecant. Draw the sine function first, like a dotted line like I've done. Draw your vertical
I go
asymptotes on
to
x-intercepts.
graphing
and
this
then
at
draw
the
cosecant.
harbor. Why
It's
don't we
much
have it
easier than
done?
trying to
CDC
memorize,
numbers.
what
I'd
that-
take him
that
over
looks
there.
like.
He
If
should
you
be able to
have it,
graph
great,
it, but he doesn't
but
want to get
this
off
is
the
a tool that
hillside.
gets you to
Plenty of
memorize.
people where
So
he
that's
is
the
the
idea.
calculus fucking teacher determining what terminal velocity is of
And
the
that's really
scientific
it.
rigor of
Cosecant
that
is the
test.
reciprocal of
Gripping
sine.
you, dipping you in the acid. Catch you next one.